Okay, so today we're going to be learning about something called explicit formulas, and I'll explain this little symbol for the explicit formulas for sequences in a little bit. But let's first talk about what is a sequence. A sequence, first off, is just an ordered list of numbers, as it says right here. Now, or it could be objects as well. And another thing to know is that when we're dealing with a sequence, the domain is always going to be the set of all positive integers. So for example, let's look at this particular ordering of objects down in this activity. What we have here is our first term is right here. Our first term, we have 1 dot. When we move to our second term, which would be this one here, you can see that we have 3 dots. When we go to our third term, you can see that we're adding, we have the 3 previous dots, plus we're adding 3 more, for a total of 6 dots. And the next term, we have the previous 6 dots, now we're adding 4 more, so we get 10. And to the last, at least the picture that we have the previous 10 dots, plus we're adding 5 more, for the fifth term is 15. Now, the thing about a sequence is you should start to see a pattern. Like here, you can see that we might increase from the first term to the second term. We increase by 2. From the third term, or from the second term to the third term, we increase by 3. So basically, what we're doing is we're taking the previous term plus the term numbers. So 6 plus 4 gives me 10. 10 plus 5 gives me 15, and so on. So to come up with I don't want to sit here and come up with other pictures, so to follow the pattern, the next term of the sequence, I would take 15 plus 6 to get 21, 21 plus 7 to get 28, 28 plus 8 to get 36, and 36 plus 9 to get 45. So now the way that I would look at this is my sequence is what I have written here in red. The sequence is 1, 3, 6, 10, 15, 21, 28, 36, 45, and so on. Now, if I want to refer to a certain spot in the sequence, the way I'd write it is I'd say this. This refers to the 8th term in the sequence equals 36. Now, what we have, the way we call this is called, the way that we'd read this is T sub 8, and that's all described down here in this paragraph. Again, this sequence defines a function whose domain is a set of all positive integers. Remember, positive integers are numbers that don't contain decimals, but they're all our positive and negative numbers. But this is referring to just our positive numbers. Another way to look at this is our natural numbers. Remember when we talked about those different categories of numbers? If you forgot, you might want to look back at lesson 1.1 or 1.2. where we talked about the different categories. But we use subscripts to locate the position, like I had T sub 8 here. So that's called a subscript. Do not write this like T times 8. It's not T to the 8th power. It's the opposite of an exponent as far as how you'd write it. It's T sub 8, meaning that 8 represents the location in our sequence. What it equals to is the actual number in the sequence. Now, let's say if I wanted to find the 15th term of the sequence. Well, for one, I don't want to do 15 sets of dots. I don't want to continue this table out to figure out what the 15th term is. It'd be really nice if I could get directly to our answer. Well, that brings me back to this symbol that I created up here. Now, you recognize this as the parental advisory sticker that you'd see on some CD cases. But basically, when you think about, or what I think about when I hear that term explicit, is I think of something that's controversial, something that's in your face. It's direct. Okay? That's how I want you to think of it. When you think of the term explicit, I want you to remember this symbol, and remember that it's direct. It gets directly to your answer. So if I want to figure out the 15th term of the sequence, I want a formula that will get me directly there. Well, that's what I have down here, where it says explicit formulas for this activity is T sub n equals 1/2 n times n plus 1. For example, n in here, first off, represents the term number. So if you wanted to find, let's do something simple. If I wanted to find the fourth term in the sequence, I would take and put 4 in this equation. Well, 4 plus 1 is 5. Half of 4 is 2. And 2 times 5 equals 10. Well, let's check our answer with this table. And sure enough, the fourth term was 10. So that's what the explicit formula does. So now if I wanted to find the 15th term in the sequence, I would just plug 15 in there for n, and I could get directly to my answer without having to complete a table. Well, let's look at this example. It says, suppose you flip a coin until it comes up tails. The probability that you will not have had an outcome of tails after n flips is given by this sequence. P sub n equals 1/2. That's supposed to be to the nth power. Change that typo. Okay, so here's how we're going to write this out. I want to find the first term in the sequence. So the first term in the sequence would be p sub 1, and that's equal to 1/2 to the first power. Well, 1/2 to the first power is just going to be 1/2. To find the second term in the sequence, I'm going to have 1/2 squared. Now when we square something in parentheses, everything gets squared. The 1 gets squared, so that's 1. 2 gets squared, so that's 4. So it would be 1/4. I'm going to leave these as fractions, so I can put it in the graph over here in a second. Oops. So the third term of the sequence is going to be 1/2 cubed. And 1 cubed is 1, 2 cubed is 8. And lastly, the fourth term of the sequence means I'm going to have 1/2 to the fourth power. Again, 1 to the fourth power is 1, 2 to the fourth power is 16. So the numbers in my sequence, the first 4 terms in my sequence are 1/2, 1/4, 1/8, and 1/16. So when I go to graph this, the x-axis is going to represent your term number. So the first term would be 1/2. The second term would be 1/4. The third term, 1/8. The fourth term, 1/16. Now granted, there would be more values if I continued, but we're just graphing the first 4 terms here. Notice something else. I'm not connecting these points with a line. Connecting these points for a line indicate that I'm including the values between 1 and 2. Well, I don't have a term number, that's 1.8. I don't have a term number, that's 3.1. So the only term numbers that are in my domain are going to be my integer values. So that's why I don't connect these with a line. Let's skip this example for now. Basically, for this one, we would do the same thing as the previous. You just plug different term numbers in for n, so it would be 3 to the first power, minus 4, 3 to the second power, minus 4, and so on. Actually, I forgot to do part B here. Let's look at that one. P sub 20, let's evaluate what that would be. Now, P sub 20 means that, what I would do is I'd put 20 in for n. So it would be 1/2 to the 20th power. Now, if you do this on your calculator, instead of typing it in as, or getting a decimal as an answer, I'm going to do it as a fraction. That'll better help me explain what it represents. And 2 to the 20th power is 1,048,576. Now, it says explain what it represents, and you'll be asked to do that in your assignment, and you'll be asked to do that on a quiz or test possibly, because it's important to recognize what our answers mean. So for that, I go back to the original question. It says this equation gives us the probability that you will not have had an outcome of tails after n flips. So what this means is after 20 flips of a coin, the probability of not getting tails is about 1 in 1,000,000. So it's very slim possibility. But if you're watching Dumb and Dumber, I suppose you could look at it that you would still have a chance. Okay, let's look at another story problem here. And we'll end with this. With this story problem, it says it is common for people to save money in savings accounts, such as certificates of deposits. And don't ask me how that got changed to degrees. I have no idea, but it should say certificates of deposits, that yield a high interest rate paid once a year. Okay, so with a CD, you get the interest, but you don't get the interest till the end of the year. Suppose you deposited $28,700 and expected a 4.1% interest rate to be compounded annually. Now, we haven't talked about compound interest yet, but that's going to be something we'll be talking about in a future chapter. So they give us the formula, the explicit formula here, that gives your total savings at any time during the year leading up to the nth anniversary. Now, that's important. I want to focus on part B right now. It says compute the 100th term of the sequence. What that means is I want to find what S sub 100 would be. So what I do is I put 100 in here for n. Now 100 minus 1 is 99. So I'm just going to simplify that piece. And we would type that into our calculator, and if you did, you get an answer of 1,532,865.74. Now it says, we're going to change this to part B. It says, what does your answer to part B mean in the context of this problem? Now it does not mean that after 100 years, we would have $1,532,865.74. The way you phrase things are very important, because this doesn't mean that after 100 years you'd have this much money. It would mean that leading up to the 100th anniversary, you would have $1,532,865.74. So you want to make sure that you put it, they'll always indicate how it's going to be phrased in your story problem. So when they describe the value of n or whatever the variable is, that's where the hint will be. So in this case, it's leading up to the nth anniversary. So we'd say leading up to the 100th anniversary, you would have $1,532,865.74. So in a nutshell, that is how we find and use explicit formulas. So good luck on your assignment.